Hello everyone! Welcome back to Chapter 9, Differentiation. Previously, we have learned about 9.1, derivative of a function. Therefore, in the next few videos, we will learn about 9.2, rules of differentiation. Let's get started. The first rule of differentiation is the derivative of a constant. So, whenever you have fx equal to k, where k is a constant, hence f prime x is equal to 0. So let's look at example 3, question A, where fx is equal to 5. So 5 is a constant. Hence, f prime x is equal to 0. Let's try again. We have fx equal to ln 8, and ln 8 is also a constant. Hence, f prime x will give you 0. The next rule of differentiation is called the derivative of a function of the form x to the power of n. So, whenever you have fx equal to x with the power n, when you find f prime x, what we need to do is to bring the power to the front and then copy down x, then minus the power by 1. So, you will get nx to the power of n minus 1. Example 4, question A, give you fx equal to x to the power of 5. So the power is 5 and you have x as your base. So f prime x is, bring your power to the front. So you'll have 5, copy down your x, so x, and now your power is minus 1. So the answer is 5x to the power of 4. Let's try again for question B, where fx equal to zx, which is also equal to x to the power of 1 over 2. Hence, f prime x is equal to, bring the power to the front, 1 over 2, copy down your x, and now your power needs to be minused by 1. So you will get 1 over 2 x to the power of negative 1 over 2. Do not forget that we must not have negative power. So this is also actually 1 over 2 times 1 over zx. Hence, the final answer is 1 over 2 zx. The derivative of a function of the form kx to the power of n. If you have a function fx equal to k, where k is your constant, x to the power of n, so you have power n with base x, therefore f prime x will give you k, so just copy down your constant. Now bring power to the front, and then the power will be minus by 1. So you'll have k and x to the power of n minus 1. So let's take a look at example 5, question A. So you have fx equal to 5x. So 5 is your constant. And x is actually is to the power of 1. So your power is 1. Hence, f prime x is, copy down your constant 5. Now bring power to the front, which is 1. and then you have x to the power of 1 minus 1. So 5 times 1, x to the power of 0, which will give you 5. For question B, we can rewrite gx as 4 over 3 x cubed. Therefore, g prime x is equal to 4 over 3. Now bring power to the front. And now x is to the power of 3 minus 1. Hence, the final answer is 4x squared. The next rules of differentiation is called the derivative of a sum or difference. So if you have a function hx equal to function fx plus minus another function gx. Therefore, when you want to find h prime x, you need to differentiate fx to get f prime first, and then plus minus, now differentiate gx to get g prime x. Hence, this means that you need to differentiate each one of these separately. Okay, let's take a look at example 6, question A. So here you have x to the power of 4 plus x to the power of 2. So differentiate fx to get f prime x. Okay, so differentiate x to the power of 4, you'll get 4x cubed. Now you plus it with, now differentiate x squared to get 2x. Okay, let's try again. Let's continue for question B. So now you have 4x cubed minus 1 over x squared minus x. So this is actually 4x cubed minus x to the power of negative 2 minus x to the power of 1. So when you want to find f prime x, this will give you 4 times 3 x to the power of 3 minus 1 minus, now bring the power negative 2 to the front. So negative 2 times x to the power of negative 2 minus 1 minus 1. So this is the power x to the power of 1 minus 1. So you will be left with 12 x to the power of 2 plus 2x to the power of negative 3 minus x to the power of 0. Now, as always, please remember that we must not have a negative power in your final answer. Hence, the final answer is 12x squared plus 2 over x cubed minus 1.